So this is lesson 1010. Through this chapter, we've been working on solving systems of equations and systems of inequalities. So systems is where you have more than one equation or inequality, and you're trying to find the solution for both at the same time. So we've looked at equations, basically where they cross on a graph, and then inequalities are going to have an entire region on the graph where all of those ordered pairs are possible solutions. So we're going to look at equations again here, but we're going to look at a nonlinear system. So one of the functions is not a line. Nonlinear, not a line. So how does that happen? We've only looked at lines so far. And so if you look at the first example that we've got here, first equation looks a little different. Second equation looks like what we're used to. This is a line right here, y equals mx plus b. Now this almost looks like y equals mx plus b, but there is a squared on the x. And when we do that, if you actually started plugging in numbers for x and then seeing what y came out to, you're going to notice that it is not going to have a consistent slope, which means it is not a line. So we're going to think about what that's going to look like on the graph. So we're going to use a graphing calculator. And if you just follow these steps, it gets you to where you need to go. So very simple use of the graphing calculator. We haven't done a ton with it this year, so we'll go through slow. This is being recorded during a COVID year, so some of you are at home. If this is being viewed in future years where all of you are here in the classroom, then you'll all have a calculator and you can follow along. But for those that are home watching this and you don't have a calculator, you can just follow along. Hopefully you can pick up on some of the keystrokes, but tomorrow when you come into school, we will practice more of this together with the calculators in your hand, so you will get better at it. But for those that are here, please follow along with the calculator, pressing the buttons, and then you'll have a chance to try some on the back. All right, so first thing we're going to do, step one, enter both equations on the graphing calculator. So how do you do that? First of all, make sure plot one is turned off. So what is that even talking about? So anytime you want to enter, so if you're on your home screen, if you want to enter an equation in to be graphed, you press the y equals button. Okay, and that brings up all of these equations that you can fill in. And then whatever you put in there, it will put on the graph. It will give you a table. And we've dabbled a little bit with this. And so if y equals negative x squared plus 3, I'm going to type this in. Let me make sure you can see the whole calculator here. So my negative button, you can't use a subtraction. You got to use the negative, so not subtraction. Negative. X is right next to the green button right here. And then if I'm going to square it, I can hit the squared button or I can hit raise to the second. Both will work. But when I do that now and I go to do plus 3, so let's say I just hit plus 3. Notice what happens. It puts that plus 3 up there in the exponent and it says negative x to the 2 plus 3. And that's not what we want. We want the plus 3 separate from that exponent. So I'm going to clear that out. Negative x squared. And then before you do plus 3, you got to hit this to the side. So you see the cursor drops down, and now we're typing there again. So before we put this in, let's go ahead and hit graph. And you can see that is not a line. It's called a parabola, and we're going to study these as well later in the year. So there's a definite curve to it. It does not have a consistent slope. And if you're not seeing it in your window, what I want you to do is press the zoom button and then press number 6, zoom standard, and that will get you to this screen. All right, let's go back to y equals. Let's go ahead and enter the other equation in our system. So negative 2x plus 3, and graph it. And that is a line, as you can see right there. So that's a straight line, and you can tell it hits the parabola there twice. And step 2 is to graph this. So if we're going to sketch this accurately, you can see this is up 3, 1, 2, 3, where this parabola hits. And then as it curves down, just before it gets to 2 and negative 2 is where this cuts through. So it doesn't have to be perfect, but it should cut down just before the 2 and the negative 2. All right. And then this line looks like it hits right on that 0, 3 there. And then it hits just underneath here. So it looks like it's hitting in these 2 points. And so it's something like this. Normally I'm not a very good artist, but that's pretty good for me. But it's just a sketch. The important part is going to be step 3 right here. So what have we been doing with these systems? We've been looking for the answer, and when it's on a graph and it's an equation, it's the point that they cross. Now, this one crosses in 2 spots, which means there's 2 answers. Okay, and that's fine. But this point right here, it looks like 0, 3, and we're going to test it and find out if that actually is the point that they cross. And then this one over here, not quite sure. We'll take a look and figure out what that is as well. So we're going to go ahead and do step 3 together. You're going to use the calculate button, which it shows you how you get there is you hit second and then trace. So calculate is right here in blue above the trace button. So to get to it, you hit the blue second key and then the trace button to get to it. So second, calculate. And what we're trying to do is find the points of intersection. So take a look, where's intersect? That's number 5. And we have used this before with that first curve, second curve stuff. And so you could have a graph, it's possible, that has 6 lines on it. And so when you ask the calculator to tell you where's the intersection, you have to also tell them, well, which 2 lines or which 2 functions are you trying to find the intersection of? Because there could be multiple lines and multiple intersections. And so for us, when it asks first curve, second curve, you can just hit enter and then enter because it's automatically going to pick those 2 because they are the only 2. But if you want to scroll to the left before hitting enter, you can see first curve is talking about the blue one, hit enter. Second curve, you can see, is talking about that line. We would hit enter. So again, if there was like 3 or 4 other lines on this graph, you might have to scroll around to find the line that you're actually looking for the intersection with. So in this case, there's only 2. Now when it says guess, after you hit first curve, second curve, you want to scroll over next to the intersection because there could be more than one. And so the calculator needs to know which one you're looking for. So I'm going to look for that one. I'm going to hit enter. And that didn't really come out to a nice number, did it? So sometimes this happens when you start scrolling all over the place. So I'm going to redo it. Hit second and then trace, intersect. Instead of scrolling all around, I'm just going to hit enter for first curve, enter for second curve. Guess I'm right there. And there we go. There's a lot nicer number right there. So little trick, just little calculator savvy there. Run it through again and don't scroll all over if it gives you a goofy number. All right, so 0, 3, we predicted was an intersection. It looked like it was, and sure enough it is. And now we got to find this other intersection. So we're going to go through the same process here. Second, calculate, intersect. Now I'm going to hit enter again for first curve, second curve. But when it says guess, I don't want this intersection, I want this one. So I'm going to use my little arrow button to scroll over closer to that one and hit enter. And sure enough, it has a very nice intersection at 2, -1. And that's it. We have found those 2 intersections. So we could also have done this with just regular old lines on the graphs like we did by hand on the calculator, but it's not really necessary. But for these curves, we don't want to necessarily have to be trying to graph those, and it's hard to be really exact when you graph those, as you can see by the picture. So it's much easier to use the calculator and let it do it for you. All right, let's flip it over. Let's do a couple more together here in the notes, and then you will try a couple on your own. Those that are at home and don't have a calculator, we will do the rest of this in class. So bring this page to class tomorrow. All right, but let's walk through a couple more just so you can see it. So you're ready for tomorrow when you do come in. Those that are here in class, in person, whether that's COVID year or later, you can follow along with the calculator as we go through this. All right, so if we're going to go ahead and put this on here, we're going to go back to y equals. We got to clear these out. So clear, just starting over. So 2x squared. Hit enter. And 3x plus 2. Enter. So that's a line and that's a curve. I know that because mx plus b. And this right here has the squared. So that's going to be a parabola again. Let's see what it looks like on the graph. So we got a parabola that hits at 0, 0. And we got a line that cuts through in two different spots there. So parabola, it looks like it gets out a little bit past the second one at the top. So something like that. And then we're going to hit right about here and then somewhere up here. Again, the sketch is not the most important part. The intersection is. So we're going to hit second and trace to get to the calculate function. Intersect is number 5. First curve, hit enter. Second curve, hit enter. Now, scroll over to where you think that intersection is. Hit enter. And that is not a mistake. You can see that's a perfect decimal. Yes, it's a decimal, but it's a perfect decimal. And so it is negative 0.5 for x and positive 0.5 for y. Let's find the other intersection. Second, calculate. Number 5, intersect. First curve, second curve, just hit enter, enter, and then let's scroll up here. And you can see I didn't get right on it. It doesn't have to be perfect. Just closer to that one than this one, and it knows what you're talking about. And that one is 2, 8. Now notice we're getting nice whole numbers. That's because these were chosen on purpose to do that. Not every function in the world is going to cross another function at a perfect whole number. In fact, most of them won't. But these have been chosen like that on purpose so that you can get some nice answers. Let's do one more together here. Number 2. So hit y equals. Clear these out. 2x squared plus 3. Make sure you go over for the plus 3. And then 1/8. How do we get the fraction? So you're going to hit alpha and then x if you've got this. Other calculators that are older versions of this, you might have to go into math and find your fraction button there. So alpha x is the shortcut. 1/8 to the side. We don't want to put x in the denominator. We want it next to it. So scroll to the side. X squared. All right, so neither one of these is going to be a line. They both have a squared. They're both going to curve. Let's see what they look like. There's a parabola hitting at 3. There's a big wide parabola hitting at 0, 0. Now later on in the year, we'll talk about these parabolas. This plus 3 is why it's hitting at 3. And the fact that this is so wide is because this has a fraction in front of it. But right now, that's not important. Not what we're studying, but we will. So you've got your big wide parabola, and then 1, 2, 3. You've got this one here. And you can try and hit calculate and intersect and all that, but you can clearly see these do not intersect. So there is not a single point on this graph that works for either one. You could even try and hit zoom and zoom out. And it continues to be wider and wider and wider. So these are not going to intersect, which means there is not a single xy coordinate that you can plug into both of these and have it work at the same time. So this is what it looks like when there's no solution. And of course, we know you can put this symbol as well. Okay, so if they don't cross, that means there's no solution. Now, for those that are here in class with calculator, you're going to practice the rest of these, and the key will be put up, and you can check your answers and see how you do. If you are watching this at home and you don't have a graphing calculator, you can stop and you can go straight to your homework. This is not your homework, but bring this in tomorrow, and we will have a chance to work on these with the graphing calculators so that you can practice these keystrokes.